everybody.
Hi, happy Thursday.
We made it to day 3 here.
How about that concert last night, huh?
Man, who knew that's what fruit sounded like?
Those bananas can slap.
Attack of the fruits. Well, we're super excited you're here with us today. Thank you so much for coming, and hi to everyone watching on live stream. My name is Mary, and I'm part of the Google Assistant team that put together this year's I/O. Hope you're having a lot of fun, meeting a lot of cool people, and leave inspired to build new actions for the Google Assistant.
And my name's Oscar. I'm the software team lead at DeepLocal and a 4-year Google I/O attendee. I'm really excited to share all of these demos with you today.
My name's Matthew. I lead up the creative technology team at DeepLocal. And as a little background, DeepLocal is an innovation studio based in Pittsburgh. And we've been lucky enough to work with the Assistant team for a while now, showcasing new Assistant features in fun, creative ways. So to that end, a couple quick examples of what that looks like. On the left here is the Mocktails mixer. You may have seen it's been at I/O before. It's gone to the Cannes Festival. It's been pretty popular at some of our holiday parties back at the office as well. In the center here is a collaborative drawing robot we had at I/O last year, where you use voice to tell it, hey, use the red color now, or I wanted you to draw circles or squares. So you work together with this machine using your voice to create this cool take-home piece of art. And then finally, on the right, this year at CES, we created an interactive ride to show how Assistant fits into your daily life. And it was this over-the-top theme park ride with animatronics and a theme song and smoke and sound effects. So it was really cool to bring Assistant into the world in that really, extreme way.
That was an epic ride.
Yeah, definitely.
Cool. So I also want to say it's a lot of fun collaborating with the DeepLocal team, and this year's no different. Here we have a picture of our Assistant Sandbox. Thanks, Johnny, for the great picture. This year, for those of you watching at home, the Sandbox is a physical place attendees can come and learn more about our new features, chat with the teams who made them, and try out interactive demos. This year, our team wanted to make sure that you get to see the end results of what you can build using these cool features and tools. We want to make sure you leave inspired to build the same things or even better.
So this is what the inside of the Assistant Sandbox looks like. As you'll see, there are a handful of awesome interactive demos that we'll talk through during this session.
Cool, VIP tour. All right, so let's dive right in. In the very first demo, we have interactive guides on how to fold really pretty origami flowers. These are made with our new how-to templates and schema.org markup. Now, if you're a webmaster or content creator, schema.org is very familiar to you, basically highlighting rich content on your website to display on search results. Now, templates is actually even easier. All you have to do is fill out some information on a Google Sheet, and your content will be available on Google Search. There's no coding needed. It's really that easy. We already have templates for quizzes, making flashcards, games, you name it, but I'm particularly excited about these how-to templates because there's a lot of great how-to content out there. Watch a lot of instructional videos on YouTube, recipes on websites and such. So I'm super excited to see all this content accessible by voice on the Google Assistant. Matthew, can you tell us about these demos?
Absolutely. So we created this origami how-to guide that utilized the new how-to template. You see this little video of what that ended up looking like. Really what we wanted to do is show how easy it is to take YouTube content and make it perfect for use with smart displays. So we chose origami because it really shows how powerful Assistant can be when you're trying to do something when you have your hands full. So to make this demo, we had to do three things, and none of them involved writing even a single line of code. First, we created our YouTube video. In our case, we created one from scratch with this origami content, but you could reuse existing videos that you already have, and it's a great way to get even more functionality out of content that you've already worked to create. Next thing we did was go to the Actions console and told it we wanted to create a new template-based how-to. To do that, all we have to do is give it a name and tell Google how we want to invoke that action. And then what's really cool is after that, a Google Sheet's automatically created for you that we can then use as a template to fill in all our how-to information. So that's the third step here. We take that template, we give it some information like the URL to our YouTube video, and then for each step in our how-to, all we have to do is add a new row to the sheet, and we say, step 1 is at the 10-second mark, and it is fold the paper in half. Step 2 is at the 23-second mark, and it's turn it 90 degrees and fold it diagonally. So for each step in our how-to, we just add a new row to that sheet. And then when we're done, here's how it looks on our smart display. You can see we get the video of the current step we're on, sort of an outline on the left of where we are in the process. We can invoke this just like we can any other action. And you can say things like, hey, go to the next step, or repeat that step. So really great sort of bringing that how-to content into a way that you can use it while you're actually doing it. What's also nice is you can use Action Simulator like you can with other actions to really test and tune this content. So really easy to get this YouTube video into this format. So that was the how-to templates for videos. And along with that, we want to show how you can use schema.org how-to types for web content. So this video gives a quick overview about what we did. You can check this out in the Sandbox and some of the code examples at the end. But basically, we're adding metadata to web pages that explicitly calls out that it contains how-to content. So for this demo, we had to do two things. We had to make a website, and then we had to add our markup to it. Pretty simple. So here's an example of what we built for the website. In this case, we were making origami succulents. This is all normal markup, but just wanted to call out a little bit of the content that you can see. It's more than just step 1, step 2, step 3. Schema.org how-to capabilities have things like the tools you'll need, or the materials it's going to take, how long it's going to take, how much money it's going to take. So you don't have to do that, but it just shows how rich this sort of content can be and that the schema can support. So after that, all we have to do is add our markup to our web page. And you can see here we do that with a script tag. It's of type application LD plus JSON. In this case, LD stands for linked data. And you can see it's as simple as sort of defining this is a how-to. Here's the description of it. Here's some of those estimated costs and things like that I talked about. Another little chunk of it, this is for some actual how-to content. So this is a step in the how-to. It's got a title. It's got an order. We can have an image, a thumbnail, any of that sort of stuff. So all this data then gets processed, and here's what it looks like. On the left, you can see a normal search with if our web page didn't have this metadata in it, and it just is a normal title, snippet, pretty standard stuff. But on the right, you can see we get this nice carousel of the steps involved in making our how-to. It has even the materials you'll need. So for users looking for content, when they see this one, it's way more rich. They're going to see, oh, this spells it out exactly. It tells me what I need. I can see what I'm getting into. It's going to be great for all your visitors. So we had to create a lot of origami-based content for this demo, so that meant we needed to create a lot of origami. Here's a lot of some of our misfires or failed attempts. And luckily, some of this work overlapped with Bring Your Child to Work Day, so we had a lot of hands, a lot of helpers to sort of tell us where our how-tos were falling short. So that was an interesting day in the office. So here's some resources to get started as well.
Thanks, Matthew. So as a web developer myself, everything you said sounded really easy.
Definitely, yeah.
How long did it take you to get the templates up and running and also the markup?
You know, if you already have the YouTube videos, if you already have the web page, you could probably add all that in an hour.
That's awesome. So for everyone who creates content online, whether it's on YouTube or as websites, definitely check out our docs for more information. And we also had a talk yesterday from the product managers on these topics, so give that a view as well. All right, so let's go on to demo number 2. This is a really tasty one. It's our S'mores app, and it's made with app actions and slices. These are new ways where you can take your existing Android app and integrate it with a Google Assistant. That way, users can access the key functionalities of your app seamlessly with their voice by talking to the Google Assistant. All right, Oscar, can you tell us about this demo?
Yeah, definitely. Thanks, Mary. This was a really fun demo to cook up over the last few weeks. In the Sandbox, we have a few user journeys for people to try. First, you can order through the S'mores app using a standard click-through flow. The screen cap shows a user selecting a few ingredients, a toast level, a quantity, before confirming their order. The next user journey is that same flow using the new feature, App Actions. The user speaks their order via the assistant, which opens the S'mores app with a populated order, ready to confirm. As you can see, this is a quicker route to the desired action than the standard click-through flow. Finally, you can check your order status with a slice. Slices allow you to serve a custom UI within the assistant instead of searching for that info in the app. With this feature, a user can check the last order's status with little overhead. As you can see, App Actions and Slices allow for a more seamless experience between an Android app and the assistant. Let's see how the app was made. The sample was built using Android Studio for the app and Firebase for cloud processing. We first built out the basic app functionality, including an ordering flow, user handling, a previous orders list, and so on. Next, we set up Cloud Firestore to hold order and user information, and a cloud function to process any incoming orders. Then, we implemented deep links to navigate into specific parts of the app via a URL. As a side note, if this isn't a feature you're already using in your Android app, it's definitely something you want to take advantage of, as it helps you drive external traffic into your application. Finally, we had to implement the app actions and slice-specific pieces of the code. Let's see what that looks like. Here's the app actions flow from a user query into the app. The query flows into the assistant backend, which determines the built-in intent, if any. In this case, the user says, order a dark chocolate s'more from the S'mores app, which the assistant maps to the order menu item intent. If there's an app on the device that can handle that intent, the app's open with any relevant parameters, completing the app actions flow. Let's dig into the code to see how easy this is to implement. Here's an actions.xml file that exposes, as you'd expect, an app's actions. The action tag identifies any built-in intents that your app can handle. There are currently intents for food ordering, ride sharing, fitness, and finance. As a result of deep linking, you'll notice the URL schema and query parameters in some of the tags. We've defined many unique ordering queries, but in the future, you'll be able to use parameters with a query to simplify things. This means you could use something like a cracker type variable in the query definition, and then define those string options elsewhere. Next, in our Android manifest, we register the actions for our application using a metadata tag. You'll also notice some deep linking intent filters within the activity tag with the URL that matches our action. Now, when your app launches, how do you know if it was a normal run or triggered via app actions? In the main activity, we attempt to pull out any relevant data from the incoming intent. If order information is found, we populate the pending order and move directly to the order review screen, completing the app actions flow. So with a few small code additions, you can enable app actions as another entry point into your app. Now let's take a look at slices. Here's the flow of a slice from a user query to an embedded response. First, the assistant backend determines the built-in intent, the same as we just saw with app actions. A query like check my order maps to the get order intent. As you can see, all of the available items are available online in the docs, so check those out if you want to see what other intents are available. After determining if an app is installed that can handle that intent, the assistant again requests and displays the slice from the Android app. This simple flow helps users get information more quickly from your application. Now let's dive into code. Again, this intent needs to appear in our actions.xml file with a URL from the deep link. However, the fulfillment is defined as a slice rather than opening the full application. And to create a slice, we need to implement a slice provider. A slice provider builds and populates a simple UI to reveal to the user. The intents URI can be used to implement different slices for different paths. You might also have a slice for when the nearest s'more shop is open or if the s'more of the day is sold out yet. You can also define an action for when the user taps on a slice. You can even use a broadcast receiver to update a slice's content dynamically. Our app has the order status advancing every 20 seconds, which is reflected when viewing the slice. In our Android manifest, we register an intent filter on the activity and a slice provider in the application to expose those to the operating system. The intent filter uses that same S'mores last order URL to connect it to the action. Let's look at the main activity again. We look for any relevant data from the incoming intent to determine if the app was opened from a slice. In the order status case, we'll direct the user to the previous orders list. And that's really it. It's that easy to provide quick information to the user with slices within your Android app. As you can see, implementing app actions and slices allow for a cleaner user experience, which will definitely leave your users wanting s'more. Here are some resources to help you get started.
Oscar, I feel like you made everyone in the room super hungry now.
Yeah, imagine how I felt with a few weeks of development and no s'mores.
All right, so you talked about how easy it is. Same question as I gave to Matthew. How long did it take you to implement all of this?
Yeah, so if you already have an existing Android app, it would probably take you less than a workday to add your first app action and slice.
That's awesome. All right, so as a very quick recap, the first two demos, we showed you how easy it is for content creators, web developers, webmasters, and Android app developers to take your existing content and integrate it with Assistant. And that's a theme that you've been hearing across I/O Talks this year. Definitely check out the docs. We have a lot of content for you. And in the next two demos, we're going to show you how to build engaging and rich actions from scratch. So this is going to require a little more work, a little more learning, but you're going to build really cool demos or really cool actions, and we're going to show you some of that. All right, so demo number 3 is a game called Jungle Dream. This is made with our new interactive canvas, which we announced in our keynote. Basically, this is a way to build very visual and interactive experiences on smart displays. Essentially, a way to have a web view on a smart display. By using only HTML, CSS, and JavaScript, you can create full screen and customizable images, layouts, video playbacks, animations, transitions, you name it. All right, Matthew, can you tell us about this game?
Absolutely. This is, I know we're not supposed to have favorites, but this is probably my favorite demo. So you can see a video here of what we ended up building, some pretty standard chainsaw stuff on your smart display. But we're all really big fans of the Google Home Hub. So when we heard about Interactive Canvas and the capabilities it was going to provide, we were really excited about it. So what we did was built a multiplayer voice-controlled game called Jungle Dream. We took inspiration from old school adventure games where you got to, navigate your hero through a bunch of different situations, but we got to reimagine it through the use of voice, which was really cool and sort of a fun challenge. So in ours, you help your character navigate a jungle by answering some pretty nerdy programming trivia, and this is all powered by the new Interactive Canvas APIs. So for this demo, there's 2 main components. First, there's a conversational app that was built with Dialogflow, and the second's a web app that could be built with anything. And what's really cool is both of those things are pretty familiar territory at this point. We know how to make these conversational apps. We know all the powers that Dialogflow gives us. And we can write web apps in a million different ways. And what's really exciting here is the Interactive Canvas APIs bring those 2 things together. So we get the power of the conversational interface, and we have the flexibility of what web apps provide us to do the visual side of things. So part one on the dialog flow side is we now have the capability to send an immersive response. That's an update in the conversation API. And basically now we can create an intent that instead of sending a string or some text to be spoken to your user, we can send an immersive response, which is basically allows us to deliver a data payload to our web app. So here's what that looks like. This one is an example. It's part of a cloud function that sends an immersive response. If you've done anything with Dialogflow, this probably looks pretty familiar. The highlighted line here is what we're really focusing on. That's where you may in the past have just sent a string back, and that string would have been spoken to your user. Instead of that, in this case, we're sending this immersive response, and you can see we're passing it the state data. Whatever is in that state is completely up to us. In this case, we're sending that it's a player action, and its value is cut the vines because we're responding to a cut the vines intent. So that's from the Dialogflow side, getting an intent, being triggered, and then sending it down to the web app side. On the web app side, we now have access to the Assistant Canvas JavaScript interface. What that does is it allows us to receive those messages that we're sending down from Dialogflow, and also to send messages back to our conversational app. This is all done just by registering callbacks in JavaScript, and then handling these events that come in. So here's what this looks like. This is sort of a super pared down version of creating that contact and callback and setting it up. But basically, anytime we receive an immersive response, this onUpdate function is going to be called, and we're going to receive that data that we sent down. So you can see here we're checking, is the player action value in this data that was sent down? If so, we're going to handle it. In our case, we play the scene of cutting the vines. So it's that simple. What's really nice is that the Assistant Canvas interface is just brought in through a script include tag. It's attached to the window object, so it's pretty basic. But that means you have the flexibility to probably use any framework that you may want. So you could either write stuff from scratch, or if you're doing things with like React or Vue that are already handling a lot of the state management for you, this works really well because then there's no reloading of URLs or anything like that. We send these state updates. You can super quickly and responsibly update them and then respond back. So in summary, the interactive Canvas APIs are a powerful bridge that allow us to create visually interactive experiences using familiar technologies. So we're really excited to play with this more and build stuff. We're really excited to see what other people build as well. Here's some resources to get you started. I really do want to plug the Google Interactive Canvas docs. It'll get you up and running really quickly from the conversational side, set up that bridge, and have the receiving messages from the web app side. So you can build out this really quick skeleton. And once you do that, I think you're going to really be inspired to try some new stuff.
All right, Matthew, I have a very important question for you. Tabs or spaces?
I'm a spaces guy, but I don't want any trouble from those tabs people out there, so I'm trying to keep it cool.
All right. So if you don't know what we're talking about, play this game in our sandbox, and you'll find out. I also want to point out the importance of good conversation design practices here. As you're building very rich and engaging interactions with your users, understand how to build really rich dialogue is important. We have a lot of great resources on our website, so definitely check those out and learn the foundations of good conversation design. All right, so last but not least, let's take a look at demo number 4. This is a really cool herb garden made with Smart Home, and our Google Smart Home APIs allow you to interact with a Google Assistant using your hardware or IoT devices. This year, we launched a few new traits, and we built a really cool herb garden to demonstrate these capabilities. Oscar, our pun master here, is going to tell us more.
Sure thing, Mary. We don't have much time left, but I don't want to leave everyone hanging. Let's watch the demo video.
So we use the dispense trait to feed our plants the exact amount of water and humidity to keep the soil moist. All plants need a little sunshine. Our plants were looking a bit haggard, so we used the rotate trait to help us trim those hard-to-reach places. OK, Google, rotate 20 degrees.
So here's a smart home overview. I bet you couldn't tell that was my voice in the video there. Anyways, here's a high-level overview of how a smart home query turns into a physical action. A user query is processed by the Assistant backend and then pushed to your partner server. That partner server determines the device to fulfill that intent and routes a request to the particular smart home device. There are two custom components here, the partner server in the cloud and a local device with hardware and code. Let's dig into each one to see how they work. Let's start with the smart home traits that we plan to support. The herb garden highlights a handful of new traits, including humidity, rotation, and dispense. We've also included zones, which is a new property of the start-stop trait. You can think of zones as subsections of a single device, such as areas of your lawn or left and right sides of a garage. The highlight here is that smart home traits are constantly evolving to support new types of devices and actions that you can take in your home. The partner server communicates with the assistant ecosystem to expose devices, including their traits and current status. It also implements OAuth 2.0 to authenticate and verify your identity. The good thing is you don't have to spin up a new instance for different devices. The same partner server can handle many devices and device types. Our implementation was deployed to App Engine, but any publicly accessible server should work. After deploying the smart home server, you'll need to create an associated action in the Actions console. When defining your action, you'll input the URL where your smart home fulfillment lives. Now that your partner server is active, how does it actually receive a request? Smart home devices talk to your cloud fulfillment via WebSockets to handle any incoming requests from the user. But it's not enough to just receive that request. We need to control hardware to complete the action that the user asked for. The photo on the left shows the herb garden's project box. Let's take a look at the full wiring diagram to see what's inside. In the center of the diagram, we see a Raspberry Pi attached to a motor driver hat to control the plant's rotational motors. Relays are used to dispense water from the pumps and start the off-the-shelf soil humidifier. The brightness of the grow lights are controlled via pulse width modulation from the Raspberry Pi's GPIO pins. And finally, what would this system be without power? And we use transformers to pull it from wall power down to usable voltage levels. Just a note here, the smart home platform is hardware agnostic, so while we use the Raspberry Pi, you could use almost any hardware that allows for a web connection. To summarize, a smart home query travels from the user's device to the assistant backend, through your smart home fulfillment server, and down to the local device. Our fulfillment server was deployed to App Engine, and we used the Raspberry Pi to control external hardware. As an extension of this project, we could use the new local home SDK to bypass the fulfillment server entirely for a more streamlined local path. To help you get started, there are full build instructions and code available in the GitHub README. We can't wait to see what kind of smart home devices you all create.
I actually just want the herb garden for my own place.
Yeah, it'd be super convenient.
Nice in the kitchen, for sure.
Yeah, right? All right, so there you have it. We just went over 4 really cool actions in our sandbox with 4 very different development journeys. As you can see, and the things that you've been hearing at this I.O., we have something for everybody. So if you're a content creator or you are a webmaster or a web developer, check out our new how-to templates and schema.org markups so that your content can be easily accessible to new users on the Google Assistant. And if you're an Android app developer, think about what key functionalities of your app you want to make available on the Google Assistant, such as toothbrush moments or things where users can re-engage. And if you're itching to build something new, check out our new interactive canvas. We can't wait to see what kind of fun games you all come up with. And then finally, if you want to build cool hardware, check out our new smart home traits and our smart home docs. We're excited to see what awesome actions you all build, so if you publish anything, definitely let us know by tagging us on Twitter or checking out our new Reddit community. We're really excited for everything that is in store, and we hope that you leave with a great foundation to build really awesome actions. And if you see something cool, check back with our sandbox. You have a couple of hours left. So thanks for joining us, and have a great rest of the day.
Thanks, everybody.
Thank you.